So in order to use our calculators to calculate the mean and the standard deviation, first we're going to have to create a list for the profits. And again, we already have a probability list. Mine's still stored in list 2. So I'm going to go to edit my lists, and I want list 4 to be these values. I could enter them individually, or I could tell my calculator to make list 4 equal to the values that are in list 3 minus 100, and it'll put all of those values in automatically for me. So then to calculate the mean and the standard deviation, I'm going to go to my calculate menu. I'm going to run one variable stats, and I want list 4 for my list because that's the values that contain the profits, V. My frequency list is still list 2. And then I can go to calculate. So I got that the mean for V is 462.5. The standard deviation for V is 163.4587. So the mean is 462.5. This means that on average, Pete will make a profit of $462.50 from a trip. That's his average profit for his trips. The standard deviation is 163.4587, which means that the profit that Pete makes per trip typically differs from the mean. By about $163.46. For part D, you're supposed to use your calculator to graph and compare the probability distribution of C and D. So I still have my distribution for C in plot 2. Again, if I do zoom 9, I don't get a good distribution, so I'm going to alter it just a little bit. I'm going to go to the window. I'm going to make my minimum 150, my maximum 1050, and my X scale 150. For my Y max, I'm going with 0.5. You don't have to do that, but you'll get a lot less dead space. Oh, I've got 2 stat plots on. This one off. Okay. So that was the same distribution that we calculated for C yesterday. So now I'm going to go to plot 3. Let's turn plot 2 off. Plot 3. I'm going to turn it on. This time my values are in list 4. My frequency list is still list 2. Again, if I do zoom 9, I'm not going to get the best window, so I can alter it. For my X-min, I'm going to go with, well, our minimum is 200. So we'll go with 100. Our X max is 800, so I'm going to go with 900. They each differ by 150, so we'll keep that same scale as before. And again, to get rid of the dead space, my maximum Y value is going to be 0.35. I'm just going to go with 0.5. And so that ends up being our distribution for V. So if you compared those with the neighbor, then what you should have seen was that the shape of those two distributions was the same. So the two probability distributions have the same shape. The mean of C, mu of C, is equal to 562.50. And the mean of V, mu of V, was 462.50. And so when we compare them, we can see that the mean for V was equal to the mean for C minus 100. The standard deviation of C was 163.46. That's the standard deviation of C. It's 163.46. And the standard deviation of V, oh, not mu, that'd be the mean. The standard deviation of V, sigma of V, was also 163.46. Thus, there was no change to the standard deviation. In other words, the standard deviation of C is equal to the standard deviation of V. So when we subtracted that constant, 100, the probability distribution, the shape wasn't affected. The mean, however, was. It was decreased by that same amount. But the variation, the standard deviation, was also not affected. So then what we saw is that adding the same positive number A, or subtracting A from each value of a random variable, is going to add A to, or subtract A from, not just the mean, but all measures of center and location. Measures of center and location. And again, we're talking about things like the mean, median, quartiles, and percentiles. However, it does not change the shape or measures of spread. Such as the range, IQR, or standard deviation. And again, these rules make sense with what we've discussed previously when we were looking at data sets and we added or subtracted a value from everything in the data set. We saw the same thing. The adding or subtracting basically took the distribution and shifted it one way or the other, changing the location and the center, but having no effect on the spread and having no effect on the shape of the distribution. So what happens if we have multiple transformations to a set of data? Maybe we multiply and add, or we divide and subtract. How would that affect our distribution for our random variable. So suppose we had gone directly from the number of passengers X on a randomly selected Jeep tour to Pete's profit V. V would have been equal to $150 times the number of passengers. That's our C value, how much we collect. But then we'd have to subtract 100 for that. I guess I should write that there in equation. V would be 150 times X minus 100. Or we could write it like negative 100 plus 150 X. And this is typically the way that we see it written. The value that we add or subtract, the value that we multiply or divide by. So now what I'd like for you to do is partner up with somebody. One of you should look at the distribution of X. One of you should look at the distribution of V. I want you to compare them and then tell me what in general these linear transformations effects have on the random variables. So what happens to the shape, what happens to the measures of center and location, what happens to the measures of spread.